What happens when you split something so small? It could wipe out an entire city. That's not science fiction. That's an atomic bomb, and it doesn't just blow things up. It turns the tiniest pieces of matter into a chain reaction that releases a fireball hotter than the sun. From a neutron you can't see to an explosion that reshapes history. But how is that even possible? What's inside an atomic bomb? How does it really work? And how can something invisible be the most dangerous thing humans have ever built? Let's crack it open, piece by piece. To understand the bomb, we need to start incredibly small. Everything around you, air, trees, your phone, you, is made of atoms. These are the building blocks of the universe. And inside each atom is a tiny center called the nucleus, made of protons and neutrons. Electrons zip around the outside like tiny high-speed satellites. Now, most atoms are stable. They're balanced, calm, and hard to break. But some, like uranium-235 or plutonium-239, are unstable. They're heavier and kind of like a shaky stack of books, ready to fall apart if you poke them just right. If you fire a neutron into one of these unstable atoms, something wild happens. The atom splits. This is called nuclear fission. And when that atom splits, it doesn't just break. It releases a huge burst of energy and shoots out a couple more neutrons. Those new neutrons go flying and crash into more atoms, splitting them too. And those atoms shoot out even more neutrons. The process repeats, faster and faster, in a chain reaction that snowballs into a massive release of energy. It starts with one atom, but in less than a second, it's a billion atoms splitting at once. But here's the twist. This reaction doesn't always work on its own. If those flying neutrons miss and escape before hitting another atom, the reaction stops. No boom, just radioactive frustration. To make sure the reaction continues, the bomb needs something called critical mass. Enough radioactive material packed tightly enough that the neutrons can't escape. They have no choice but to keep the reaction going. Think of a room filled with mouse traps. Now imagine that every trap is holding two ping pong balls. If you throw one ball into the room, it hits one trap. Then that one sets off two more, and then four, and suddenly chaos. That's the chain reaction in action. The atomic version just replaces ping pong balls with neutrons, and the chaos with a nuclear fireball. Now let's talk about the real magic trick, how such a small thing creates so much power. The explosion of an atomic bomb doesn't come from fire, or pressure, or chemicals. It comes from matter itself disappearing. When an atom splits, a tiny bit of its mass vanishes, but it doesn't go to waste. Instead, it transforms directly into energy. This is what Einstein's famous equation, E=mc² is all about. E means energy, M is mass, how much stuff you have, and C2 is the speed of light squared. Since the speed of light is already enormous, squaring it makes it astronomical. So even the tiniest bit of mass, like a speck of dust, becomes a jaw-dropping amount of energy. That's why just 0.7 grams of uranium, less than the weight of a paperclip, can flatten an entire city. It's like turning a single snowflake into an avalanche, or a single grain of rice into a lightning bolt. This isn't chemistry, it's raw physics. The universe tearing at its own seams. Now that you understand the science, how do humans build something that dangerous? Let's break it down. There are two main types of atomic bombs. The first is called the gun type design. It's simple and was used in the bomb dropped on Hiroshima. Here's how it works. Inside the bomb are two separate pieces of uranium-235. On their own, they're not dangerous, but the moment they touch, they can go critical. So, the bomb uses a small conventional explosion to fire one piece of uranium into the other, just like shooting a bullet down a barrel. When the two pieces collide, they instantly form a critical mass. The chain reaction begins, and within microseconds, the city below disappears in a white flash. The second design is called the implosion type, and it's much more sophisticated. This one was used in the Nagasaki bomb, and it uses plutonium, which is harder to trigger. Instead of firing two pieces together, the implosion bomb surrounds a ball of plutonium with precisely shaped high explosives. When triggered, these explosives detonate inward at the exact same moment, crushing the plutonium into a smaller, denser shape. This rapid compression forces the atoms close enough to reach critical mass in a flash. Think of it like squeezing a rubber ball with hundreds of hands all at once. useless. Only your hands are made of TNT and the ball turns into a star. But even that perfect setup isn't enough. The bomb still needs a final kick, a way to make sure the chain reaction starts exactly when it should. That's where the neutron initiator comes in. Right at the moment the core is crushed into critical mass. A tiny device inside fires off a burst of neutrons into the heart of the plutonium. These neutrons are the final spark, the match that lights the invisible fuse. Without them, the bomb might fizzle. With them, the atoms don't just split, they race to do it. In less than a millionth of a second, the reaction is fully underway. And from that moment on, there's no stopping it. The moment the reaction begins, the world changes. Three terrifying things happen all at once. First, a fireball forms. The core becomes hotter than the surface of the sun in over 1,000,000 degrees in a fraction of a second. Everything nearby, buildings, trees, people, instantly vaporizes. Second, a massive shockwave bursts outward. The air itself becomes a weapon. It rips through cities, flattens structures, and throws vehicles like toys. The sound of it can break windows miles away. And third, radiation. It spreads invisibly, quietly, and fatally. It seeps into soil, into water, into skin. It lasts for years, sometimes decades. The atomic bomb doesn't just destroy in a moment. It leaves behind a ghost, an invisible poison that keeps killing long after the blast is gone. So how does an atomic bomb work? Not with fire, not with hatred, but with a whisper of science. It takes something you can't see, an atom, and splits it. That split unleashes a chain reaction. That reaction becomes heat, light, sound, radiation, and silence. The most terrifying weapon humans ever built doesn't shout, it doesn't scream, it just starts with a spark and ends with nothing.